So chapter 3, we're talking about rational numbers. Page 94 is where 3.1 starts in your Pearson Math Makes Sense textbook that some of these notes are based off of. And the unit 3 is rational numbers, so we're going to talk about those. We're going to go over some definitions here first, so that you have an idea of what we're talking about for as far as meanings of words. And most of these should be, I guess, words that you've heard before. So here you see on the notes in front of you, you should have these notes here, and you'll see that there's a number line. There's a number line here. You guys have those? Is it frozen? It's frozen. Okay. How's that? So we have a number line here, and we have some numbers that are placed on the number line. Okay? So let's talk about these definitions, and we'll point out some of these numbers here and identify what they might be. So integers. Okay, what is an integer? Does anybody have any idea what an integer is? I want to take any and all guesses. Yeah? A positive or negative number. Okay, that's close. Thank you for that. That's very close. Does anyone want to add to that to make it a definition for an integer? So you said positive or negative numbers. Positive or negative whole numbers. Yes, so we actually aren't talking about decimals or fractions or square roots. We're just talking about whole numbers. So whole numbers, if you remember, are all of the counting numbers like 1 and 2, 3, 4, 5, and so on with 0. Okay, that's whole numbers. So 0 and then all the natural counting numbers. Integers adds the negative natural counting numbers as well. So all whole numbers, positive and negative, and 0, but no fractions or decimals. Okay? So take a moment to jot that down in your notes, jot that definition down. All right, positive and negative fractions. Okay, so let's focus in on what a fraction is. A fraction, you know what a fraction looks like, so this would be a fraction, this 1/2, right? This 1/2 is a fraction. This 3 3/4 is a fraction. Okay? So positive and negative fractions would be, well, positive 1/2 would be negative 1/2, would be negative 2/3. So a fraction is a ratio of whole numbers. Okay? And we're going to talk about that down here. So we know what fractions are. We know what they are to be recognized. Okay? What about positive and negative mixed numbers? Okay, so this is technically a mixed fraction. So it's still a fraction, but that's a mixed number where you have a whole part and a fraction part, right? Okay, so let me just, again, I'll just try and jot down some definitions here for you. So positive and negative fractions, well, it would be, plus or the minus sign, the negative, ratios of whole numbers, I guess. Okay, so that's a loose definition. There are some technicalities we won't get into later, like 0 can't be in the denominator, but stuff like that we won't worry about for now. So plus or minus, and you see the negatives here on the left side of 0 on the number line. Ratios of whole numbers, that's what fractions are. And we'll talk more specifically about rational numbers here coming up. Positive and negative mixed numbers. Okay, so this 3 3/4 is a mixed number, right? And so if you have positive or negative mixed numbers, that's just a special type of fraction. Okay, and again, I could say here plus or a minus or a negative fractions with whole number parts and fraction parts, I guess, if you want to call it that way. Okay, so if you're writing that down, you should be writing these down, but that's what you might want to write for some definitions there. Repeating and terminating decimals. Okay, so remember what repeating and terminating decimals are from the previous work that we've done here. Repeating decimals are decimals that do not ever stop. Terminating decimals stop. Repeating decimals, these are decimals that have one or a chunk of numbers that repeats in the decimal. Okay? So I won't write the definition down because we spent lessons on this. So repeating or terminating decimals. So it's important here to notice that this is what rational numbers include, all of these. Okay, rational numbers, including repeating and terminating decimals. And that's maybe the trickiest one because non-repeating and non-terminating decimals, which we've talked about before, we said that those indicate that the square might not be a number might not be a perfect square, right? If the square root is non-repeating or non-terminating. So we talked a little bit about what that tells us. But now, only repeating decimals and terminating decimals are considered rational numbers. Everything else is called irrational, but we will continue on with that. So basically, to sum all this up, a rational number is any number that can be written in this form. That is m over n, where m and n are both integers. Okay? So this is super important right here, and you should have this in your notes. Did I do blanks for you guys, or no? I don't think so. I don't think I did blanks on this one. So that's what a rational number is. Any number that can be written in this form. That is a ratio of two integers. So if you look back up at the number line here, okay, -5 can be written as two integers. That's -5 over 1. Or -10 over 2, and so on, right? So -5 is definitely a rational number. What about this one? 0.16 repeating. 0.16666 repeating forever. Okay, that's got a repeating part in the decimal. So they're saying that this should be a rational number. So we should be able to write this as some number, some integer, positive or negative, over another integer. Does anyone know what that fraction or what that rational number looks like in this form? Anybody have an idea? Why don't you get your calculators out right now, and I want you to see if you can figure it out. See if you can figure out what two numbers this makes this repeating decimal. So go ahead and take a few minutes, and you literally you want to think about this a little bit, but you might want to just do some trial and error on this, okay? So you want to have something that's pretty close to 0.1, right? Or pretty close to 15%. Right? This is 16.7%. So what ratio of two numbers would get you close to that? And go ahead and just try a few. Okay, so we got a guess of 1 divided by 6. 1 divided by 6. Let's see. Look at that. 0.16 repeating. Now, on your calculator screen, remember that even though there's a 7 there, you can't say, oh, that's not 1/6 repeating. What happens is your calculator usually rounds the last number, okay? It rounds it. So the 6 with a 6 behind it would turn to a 7. So that's okay, very good. So if you put 2 over 12 or something like that, you would have gotten the same repeated decimal as well. Okay, so 1 over 6, great. So notice that is a rational number because it can be written as a ratio of two integers. +1 divided by +6. All right. Which of the following numbers are rational? Okay, which of the following numbers are rational? So I've got, let's see, how many? 4 or 5 options here. So let's take a look at the first one. Is this a number that can be written as a ratio of two integers? Well, let's see. It's written as a ratio right now. Is this an integer? -1? Yeah. Is this an integer? Yes. 4, yeah. So this is a rational number. Okay, so remember, the root word of that rational is ratio. So can it be written as a ratio? All right, square root of 9. Now when you see a square root, you might think, oh, we've got to be careful with this, which is true. You have to be careful with the square root because many square roots are not rational. Is this one rational? Hey, it is. Many of you said yes right away. So root 9 can be simplified to 3. And of course, a whole number can always be written as a ratio. Just put it over 1. So any whole number, when simplified, is a rational. So that's great. Awesome. So here's one, root 2. Okay? Root 2. I'm going to add this one here. So as I said, when you see a root, a square root, or any kind of root, cubed root, fourth root. We won't talk too much about those this year, but a square root, when you see a square root, you have to be skeptical. Does this simplify to a whole number, or does it have, remember from our work from last chapter, the decimal, is it repeating or terminating? So you have to check that. So this obviously isn't a perfect square, number 2, that we know of, but let's check. So if we do square root of 2, 1.4142135562, it does not appear to end. We don't know for sure, but it does not appear to end. So we could safely guess this is non-terminating, and there's no bits of this that repeat. Okay? So root 2 is not a rational number. Root 2 is not irrational because its decimal is not, see, it doesn't apply to this. It's not repeating or terminating. So it's not a rational number. And we said when we talked about perfect squares, we said it's not a perfect square, right, if it doesn't do that. So this is not, as well, a rational number. Okay? What about this one? 2 root 2. Now let's say 2 root, what was the one I was thinking of? Let's say 2 root 4. Now, you can look at this 2 different ways. You can say, oh, there's a root in there, but root 4 simplifies, right? So this is the same as 2 times 2, which is 4. So that one definitely is. So you have to kind of examine the square roots a little bit. Okay? All right, let's keep moving on to C. We'll get to another square root soon. -4 over -9. Rational number? Yeah. Yes, it is. Those are 2 integers right there. Pretty easy to see. Okay, here we go. Root 75. Now here's where you have to be careful. Root 75. So is this a rational number or not? 75 is not a perfect square that we know of on that list of perfect squares, but let's check the decimal. Okay, but we always have to check the decimal here with roots. That's probably our best way to do this. So second function square root 75. Okay, 8.66025438. Does that appear to be repeating or terminating? No. So we would say no for this one. Okay. Pi. Okay, so you know about pi. Pi is a very special constant in math to do with circles. It's an aspect of circles that we use in dealing with perfect circles. And pi, what do you know about pi? It doesn't what? Yeah, it doesn't terminate. Does it repeat? Yeah. No. It doesn't repeat either. Right, so it does not repeat, it does not terminate. So this is no for a, and again, for both these are for the same reason. Okay? The decimal does not terminate or repeat when you convert it to a decimal like on your calculator. So just a note here, if something is not rational, we call it irrational. Okay? So this is irrational. You'll hear me say that and I'll expect you to use that word. If it's not rational, it's irrational. Okay? You maybe heard that in like real life, right? Well, oh, be rational about this. Quit being irrational, right? So have you ever heard that? Someone that's irrational. That person is just irrational. Yeah. So what does that mean? Like in real life? Yeah, like in real life, like in real conversation. What does that mean if a person is irrational? Sure, go ahead.
Kind of like not being fair, like not looking at both sides.
Not being fair, not looking at both sides. Okay. Anybody else? What is being irrational or thinking irrationally? Yeah?
Thinking like without thinking, I guess.
Thinking without thinking?
That's like
Okay, that's a bit tricky. So thinking without thinking. So maybe not organizing well and working through properly the thought or the idea. So kind of what you're saying. Thinking without really thinking it through all the way, not reducing it down to simplest terms. So yeah, so if we talk about irrational in our day-to-day life, you think you're not really thinking that through. You're bumbling, or you're just going on and on without actually coming to any kind of conclusion. You know, it's not based on something that's finite or that's, well, in a better sense of the word, something that's rational or reducible down to something that we can identify. You're just rambling on and not making any sense. You're being irrational, okay? Not thinking through this clearly. So in a sense, it's a similar kind of definition. A rational number can be reduced down to a ratio of integers, okay? Not a non-repeating, non-terminating, sort of bumbling type number answer. So that might help you think about rational and irrational, okay? All right, on your assignment there, we've got a few questions noted here. Why don't we take a look at some practice your skills questions. Oh, you guys, yeah, we have 6, 7, and 12 here. It looks like 7 didn't make this cut. So let's take a look at your textbook here now, and let's work through some questions based on what we have learned so far. All right, so these are some questions from your text here. So this first one's number 6, and here's number 7. And so let's take a look at each of these and see what they ask us to do. For each rational number, write 2 fractions that represent the same number. So equivalent fractions. You guys should know all about equivalent fractions, right? From your work in previous grades. So if we have, let's say a is over here, 7 over negative 9. How do you make an equivalent fraction? How do you do that? What do you do? Okay, so you multiply or divide the top and the bottom by the same number, okay? To get either, numbers that are bigger if you multiply maybe, or numbers that are smaller if you can divide. So getting to the simplest terms in a fraction would be dividing by the same number. Now, with 7 and 9, we can't pick like a whole number or an integer that we can divide both the top and bottom by to reduce this down any further. This is already in simplest form. But we can multiply, let's say multiply, and we don't want to multiply by 1, right? Because that's the same number. So let's multiply by 2 or 3 or 4 or something like that. I'm going to pick 2, and that's going to make this equal to 14 over negative 18. Now this negative sign could be on the bottom or the top. Or actually it could be on the side. Each of those 3 are equivalent. So this is a negative rational number. That's a negative rational number. And so is this. So the position of the negative sign, as long as there's only one, doesn't matter if it's top, bottom, or on the side. Okay, so just keep that in mind. All right, that's 1. And what's another one? Well, we could multiply 7 times 3 to get 21. And we could multiply negative 9 times 3 to get negative 27. So those are some perfectly good answers for A there. All right. Now I won't do all these ones. I'll just do some sample questions here. Number 7 says write each rational number as a decimal. So all of these are rational numbers because we can see that they are written as ratios. Numerator is the top, denominator is the bottom. They're ratios of integers. So 6 over 5. You can get on your calculator there and you can say, Mr. Calculator, I want you to help me here. I'm going to do, let's clear this actually. Let's do 6 divided by 5. And I've got 1.2. Okay, let's stop and think about this for a second. This clearly is a rational number. Does the decimal reflect that this is a rational number? Yeah, does that look to be terminating or repeating? Yeah, it's terminating. There's only one decimal place and it stops. So that's terminating. Awesome. So we want to note that. So 1.2. This is a rational number we can see, and the decimal means that this is a rational number as well because it terminates. Okay? Now, 9 over 4, let's take a look at 9 over 4. And I'll just simply do 9 divided by 4 on my calculator. And I get another decimal that appears to terminate. Can I just note here for you that because you see 2 2s here, don't say, oh, the 2's repeat. That's a repeating decimal. It's not a repeating decimal. Okay, a repeating decimal would be one number or a collection of 2, 3, 4 numbers that repeat every time over and over and over without stopping. So this one is just like a 2 and then a 2. That's not repeating. Okay, it has to be really behind the decimal is what you look for, the repeating parts. Okay, so this is a terminating decimal. 2.25. Any questions there so far? Okay, so what about number 12? 12 says write 3 rational numbers between each pair of numbers. Sketch a number line to show all the rational numbers. Okay. Sketch a number line to show all the rational numbers. So I wonder if that's for the whole question. I suppose it could be. You could write one number line for all of these, perhaps. You could do a separate number line for each question too. I'm not really 100% sure what they're wanting there. But 3.7 and 4.2. Okay, so if we have 0 here, 1, 2, 3, 4. So 3.7 would be right about here. Okay, I'll make a little dotted line. And 4.2 would be right about here. Now, there are really an endless number of numbers that you could write that would fit between there. And the reason why I say endless, because you could write decimal numbers that have many, 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 many decimals, right? Numbers. So, for example, 3.72. That's in between because it's just greater than 3.7. You could make this 5. You could make this 110. 2, 9, 3. I mean, you could go on forever. So there really is an infinite number of numbers between any two numbers on the number line, which is mind-boggling in itself. But it can be any random number that is between 3.7 and less than 4.2. Okay? Now, you could put whatever those two numbers are just on your number line. So my 3.725 is right there. And I could go 4.011, and that's just above 4 right there. Those would be random ones. Negative 1.5 and 0. Okay, so negative 1, here's negative 2. So negative 1.5 would be right here. So there's lots of options here. You could go anywhere around negative 1. Okay? So you could go, remember, don't go negative 1.6, right? Because that's a little bit beyond this. That's not between here and here. So we've got to go somewhere around negative 1. So you have to put negative, I'm going to say 0.99. That's 1. Okay? And negative 0.05. Those are just my two random ones, and that one's going to be there and there. Okay? So those are just two examples for A and B. You can go ahead and finish. Why don't you finish at least C and D there now that you've got a chance? And I'll reveal. Or actually, you can make some guesses for C and D, and then I'll get you guys to shout out your answers, and we'll double check to make sure those are correct. So finish C and D, and then we'll check to see if you're on the right track here. What are two numbers for C? You don't know? Really? You don't have any idea? You didn't write anything down? You have no idea? Okay, well, did you write the number line? Okay, so negative 4.5, here's negative 1, here's negative 2, 3, 4, and here's 4.5. Okay, how's it now? So there's 5 and there's negative 4, right? So if you didn't have anything written down, this is what you do, okay? So between negative 4.5, that's right here, and negative 4 is right here. So on that visual number line, what's one decimal between negative 4 and negative 4.5? What would be right in between there, maybe? Any number. Would negative 3 be in there? Would negative 3 be in between there? Where's negative 3? Negative 3 is right here. So that's not in between there. Okay, anybody want to help her out? Yep. Negative 4.6 is not in between there. No. Let me blow up this number line for you. If you need to, go quickly. Here's negative 4. Here's negative 4.5, guys. Okay? So what might be in between here? This is not hard. You need to know how to do this. Okay? Negative 4.6 would be out here, right? So negative 4. Okay, I think I heard a negative 4.53. That's out here as well. So negative 4.1. Yes. Negative 4.1. Easy. What's another one? Thank you. Negative 4.2. Okay. Are we getting it? Draw your number line. Write it down. All right, D. I'm not letting you off the hook. Hey, you getting that message? Right? Okay. So D. What about D? Here's 4.5 already. 5.6 would be way over here. Negative 5.6 somewhere. So I need something between this one and this one. There's a lot of options. Someone shout out 2 for me.
5.566.
Positive or negative?
Negative.
I didn't hear you say negative. Oh, it's negative 5 point what?
5.566.
Okay, 5.566 is perfect. That's just before negative 5.6. Awesome. Make sure you have your negative in there. Another one. Negative 5.4, of course, that's here as well. So you could go anything like negative 4.6, negative 4.7, negative 4.8. You could do anything like that. So there's a lot of options. Here we go. Everybody got that now? Any questions about that? Everybody good? This side? Okay. Very important. Okay, let's keep moving on. Let's go to the next page of notes here. Okay, compare and order rational numbers. You guys have seen these this notation before, correct?
Yeah.
Right? So this is greater than, this is less than, this is equal to. So I'm not sure how you remember what symbol is what. This is what my teacher told me in elementary school. I still remember this. It doesn't help you remember which is greater than or less than. I'll get to that in a second. But my teacher always drew a little bit of an alligator here, or a crocodile, one of the two. And the alligator was always eating the larger value of like food or whatever it is. So this symbol right here, the alligator's mouth, means that this is the larger side. Okay, so I always pictured it as, oh, I want to eat the larger amount of food. Now that doesn't help us to know which one's greater than or less than. I know that this is greater than this, so if you read it like that, that's the way that you can indicate. So this is larger because the alligator's eating this side, so this is greater than. All right, this one is greater than. The other really easy way to remember is that this sort of looks like an L. You see the L here? Okay, that's an L, stands for less than. So we always read it left to right. This would be small, this would be great. So this is less than this one. So the L says less than, and this other one is the greater than, okay? So greater than, less than, or equal to. All right, so for comparing rational numbers in fraction form, decimal form's a little bit easier, although we did have a little trouble with that on the number line for some of you. That's fine, we're gonna work on that. But fractions might be a little tougher, okay? So there's different ways you can tackle comparing fractions. I wanna go over a few of these with you. If you have two fractions, getting a common denominator is going to be the easiest way to confirm this, all right? Now, you could convert to decimals, but I want you to be able to do this without just typing into the calculator and getting your calculator to blindly sort of do this for you. So getting a common denominator is how you would compare this. So 4 over 7 and 5 over 9, how do we get a common denominator between 7 and 9? Anybody remember?
Times the 9 by 7 and the 7 by 9.
Okay, so this one over here, multiply by 9. What you do to the bottom, you have to do to the top. And this one over here, if you multiply by 7, you multiply the bottom and the top by 7. So that gives us 4 times 9 is 36. 4 times, I'll just write 36 then. So 4 times 9 is 36. 7 times 9 is 63. Good. 5 times 7 is 35 over 63. Now look at this. You think about a pie or a pizza that's cut into 63 equal pieces. That would be tough to do. I don't know how we would do that, but that would be a good assignment to try and do that. But if you cut it into 63 equal pieces, then who has more pieces if I have 4/7 of the pizza or 5/9 of the pizza? Yeah, 4/7 is actually bigger because it represents 36 pieces of those 63rds as opposed to 35 here. So this one's going to be greater. So let's erase all this. Let's put a sign in there. I'm going to put the greater than sign right there. You guys okay with that? All right, so that's converting to a fraction with a common denominator. So what about this one? Okay, so we have two fractions that already have the same common denominator. So I have 8 pieces in my pie, or in my pizza, but I'm comparing negative numbers. Oh, So you have to be careful with negative numbers. Fractions that already have the same common denominator, what we have to do is we have to look at the numbers on the top, which are the numerator numbers, and we have to pick the larger numerator number. Now, when we're dealing with negatives, okay, I'll just use this line. When we're dealing with negatives, you have to be careful there that -3 is over here and -5 is over here. So the greater one is going to be closer to the right, okay? So we go greater this way. So a very large number that's negative is actually really small. A small number that's negative is actually really large, okay? So which one is bigger, -3 or -5 here? -3 is bigger, so we have a greater than here as well. Okay? So just be careful with that number line. Any questions? All right. Now, again, I would look at this and I'd say, let's just get a common denominator and be done with it. If you want if you can learn some more just shortcut rules, if you like that, if you think you can learn these, that's fine. So a shortcut rule here is this. What happens if they have the same numerator? Okay? For positive fractions, if they're positive numbers, the same numerator, okay, the fraction with the smaller denominator is greater. Now, again, I would probably just tend to find a common denominator. It's just one rule you can remember all the time. But you think about this. If you have a pizza, again, that's cut into 7 pieces, and I don't know if I could do that one. 1, 2, 3, 4, 5, 6, 7. That's 7 pieces, and if they were even, and here's 9 pieces, 1, 2, 3, 4, 5, 6, 7, 8, 9. Which pieces are bigger? If I have 2 of these pieces or 2 of these pieces?
2/7.
Yeah, 2/7 would be bigger. So if you have the same numerator, the smaller denominator is bigger. Okay? Because if you had, for example, 2/1, that's a really small denominator, and that's the same as 2 whole pizzas. Right? Okay, so that's a rule there, or you could just do the common denominator. Here, if it's negative and they have the same numerator, it's opposite. So the larger denominator is greater. Okay? So the larger denominator here, this one would be greater. Smaller denominator is greater. Okay, so those look like that. Questions so far? Some of these little rules, you don't have to memorize. Like I say, just get a common denominator and compare. But you do have to remember the negatives. The smaller negative number is actually larger. Okay, what about -3/4 and +3/4? Well, again, if you look at your number line here, if this is 0 here, we have -3/4 right here and +3/4 right here. Then the one that's positive is bigger. And this is what we call opposites. If you have the same number, but one's positive and one's negative, they would be opposite numbers. So obviously this one is greater because it's further to the right on the number line. Okay, so if we have 2 fractions where the numbers are identical, but the signs appear to be different, we have to look carefully at these. And remember what I said earlier about negative signs. If you have one negative sign in the fraction, doesn't matter if it's top or bottom or on the side, then that's the same as top or bottom or side. So these two would be equal. Okay? Yep, they would be equal because this is a -7/8 and this is a -7/8. So they're equal. Doesn't matter if the negative's on the top or the bottom. As long as there's only one, they're the same. Okay? Everybody got it? Okay, any questions about the first 6 here that we did? All right. Okay, how are we going to do this one? How am I going to find out which one is bigger here? Any ideas? Because one's a fraction, one's a decimal. Yeah. Turn the fraction into a decimal. Yeah, you could do that in your calculator, turn a fraction into a decimal. Let's say we don't have our calculators available. What could we do? Because that might be, you might know what this decimal is. You might not. That's not a hard one. But what can we do with this decimal that wouldn't require a calculator?
You could turn the decimal into an improper fraction.
Yeah, okay, you could turn the decimal into an improper fraction. You could, yeah. But then this is not an improper fraction. So I guess you could turn this one into an improper fraction as well. Oh, you said improper, not mixed. Improper. So what would that be? You're right. What would that be? Sorry?
28 over 10.
Yeah, 28 over 10 is correct. So I have this now. I'm comparing these two. So we're getting closer. We have two fractions at least. So is there a way that I can efficiently compare these as fractions? What should I get? A common denominator. That's absolutely right. Okay, I heard someone say 20. Yes, you can multiply the left one by 10 over 10 and the right one by 4 over 4 if you want. That's no problem. You might need a calculator for that. But what is also noticeable is that the lowest common multiple between 4 and 10 is 20. So I could write this as a fraction over 20, and then I won't have to multiply such large numbers. For example, I could do 4 times 5 and 10 times 5 to get 20. And I could do 10 times 2, 28 times 2. So that gets me 20 on the bottom here and negative 50 on the top. This gives me 20 on the bottom and negative 56 on the top. So these are negatives. So which one's bigger? Yeah, the negative 50 is bigger. Right, so I need to put a greater than symbol right there. Let's highlight that in red. Okay? Okay, does that make sense?
Yep.
All right. It might be easier to keep this negative sign in the numerator when you're turning to fractions like I did, just so you can compare those numbers. Because if you had a negative down here, right, and you just looked at these two numbers, you might get confused because these are actually not the same denominator, so that's the problem. So you got to keep good idea to keep your negatives in the top always when comparing. All right. You guys are doing great. So you understand the inequalities now? Okay. Okay. Okay, so here's your day one homework. Should be up on the board there. 14 will be part of your assignment, but it's optional to do for tonight. We can pick that up tomorrow. And I'll give you the rest of the questions in the next lesson.